GM everyone. G Kaia everyone. I'm super excited to be here one more time today. And yeah, I think we have quite a number of persons in the chat, GMing and also G Kaia and each other. Right. So today we'll just continue from where we stopped. So far, we've talked about blockchain 101, Kaia 101, and now we are currently, talking about Solidity fundamentals. So yesterday we went through um the basics of smart contracts, right? From setting up Remix for writing your smart contracts, for you know compiling and also deploying using Kaia plugin. Then we talked a little bit about data types, right? In Solidity, how that we have two data types, which is value type, which are also called like primitive data types, and also um, reference types, which sometimes can be called complex data types, right? Pretty much. And so today we'll just proceed from where we stopped. In today's session, we'll be looking at Solidity fundamentals 2. And yesterday we kind of like touched on quite a number of reference types from arrays to mappings to structs, but we didn't kind of like touch on strings, right? So today we'll be looking at how strings are declared and how they are used, in your contracts, especially in Solidity, right? So basically, just like we know, strings as they are used to like store textual data, right? And the way they are declared is that you use the string keyword, right? So let's just get straight into it by going to our Remix IDE, going to our workspace. So I want to assume that everybody here on this call also is on their PCs, right? I think that's like the fun of the session where everybody kind of like code along, right? Such that you get to practice what is being taught on the go. So I advise for as many of us that are on the call, kindly go over to remix.ethereum.org and let's, code along, right? So without further ado, let's just, continue from where we stopped, right? Yeah, so I think we stopped here, right? Where we were talking about reference types, right? Up to the point where we talked about arrays, we talked about structs, we talked about also mappings, right? So from yesterday's class, who can remind us what the default value of a mapping is? Anybody? Is there somebody that can remind us what the default value of a mapping is? Somebody wants to try before we. Okay, zero. Why is it zero? I mean, there should be a reason why it's zero, right? Why is it zero? Now, anybody wants to try again? A mapping is a type of like data structure that takes in key value pair, right? Yes, when a value is not assigned, it returns zero for sure. But it depends on the value type that is being assigned, right? Take for instance, if the value type is uint, it returns zero, right? If the value type is an address, it returns address zero. I hope that makes sense, right? So because a mapping is a key value pair type of like data structure, right? If your key is an address and the value is uint, the default value should return zero. But if your key is an address and the value type is a Boolean, the default value should return what in this case false, right? So that's more like the idea, and this is just us trying to recap from what we thought or what we learned yesterday. Moving forward, let's talk about strings, right? I sort of like mentioned that strings are used to like store textual data in Solidity. And so the way we kind of like work with string is to use the string keyword, right? And once this is done, you can basically set the visibility and the name of your variable. So let's call this name and let's set the name to hello Kaia developers, right? So this is how to set our strings in Solidity, as simple as this. But there are quite a number of things to note while working with strings is that you can perform some sort of like comparison on strings, or you can perform some sort of like arithmetic operations on string, like strict inequality or strict equality, right? In the case where you want to compare two strings together, probably you are writing a function that takes in a string as input, and you have a string in your contract which you want to compare each other, right? By default, this cannot work because a string in itself doesn't support this type of like arithmetic operations or this type of like comparison. But how do we sort of like bypass this will I say this limitation that strings sort of like provides us with? Now, the way to do that is to first convert your strings to bytes, right? Because under the hood, they are represented as bytes, right? And so the way to do that when we want to compare strings, right, is to convert them to bytes, right? Convert to bytes, then hash this value, and then do your comparison with the hash value. So how do we mean? Let's write a function that basically compares two strings together, right? I already give like a scenario where you're trying to compare two strings if they match, such that if it doesn't match, or you have like a name variable in your contract, and you want somebody to be able to claim certain amount of money if they can provide you that they are the person, right? And they have to provide the name that has been stored in the contract. So you have to be able to compare if the input is the same thing as what you currently have in your contract. Now, the way to do that is to use hash functions and also pack them into tight packed bytes, right? How do we mean? Like I mentioned, to sort of like compare strings, right? You have to first convert your string to bytes, right? And that's how it sort of like works. So in this case, as you can see, we are providing a storage location or like a data location to our string because it is a what? It is a reference type. We mentioned yesterday that for every reference type that you're dealing with, you have to specify where you want them, a pointer to where you want them to be stored, right? So for every reference type, you have to provide their data location. And we said that we have three types of data location. We have storage, we have memory, and we have call data. So for the most part, for variables that are stored in the contract storage, right, that sort of like persists throughout the lifetime of the contract, they are stored in the storage. Now, for variables that are not
Hi,
in
Ayo.
the, yes,
Sorry
please.
to interrupt, but I think we have a request from chat to zoom out a bit because they are coding along in pop-out mode view.
Okay.
Zoom out or zoom in? Let me,
Does this work?
yeah, let me just pay attention. Chat. Does this work, everyone? Is this better? Yeah. Okay, cool.
Oh,
Yeah, this works.
awesome.
Okay, cool. All
All
right.
right.
Please continue. Sorry about
So
that.
yeah, sure. Thanks for bringing that to my notice. So now the way to do that is to first specify the data location, which we've just done. For every reference type that we're working with, we have to specify the data location, whether it be arrays, whether it be structs, whether it be string, or whether it be mapping of any sorts, especially when you're passing them as a parameter in your function or as a return value, right? Really, really important. So what we are trying to do here is to compare two strings after hashing them, right? And that means that we want to return a Boolean. And so when we do this comparison, it's meant to return a Boolean. So that means we want to write a function that returns a Boolean if the comparison of name is equals to this name over here, right? So what that will mean is that we have to set our function to public, then use the returns keyword, right? And the return type, in this case, is going to be a bool, right? Because it either returns true or false, right? And so once this is done, we basically just use the return keyword because we want it to return the results of the comparison, right? So the first thing we want to do is to use the hash function. And so for the sake of those who sort of like were in the first class for blockchain introduction or fundamentals, we said that hash functions are pretty much used in the blockchain for certain scenarios, right? We mentioned we use our hash functions to like the um, conceal information basically, and especially for like cryptography in general, we can use hash functions to like hash certain datas or basically just walk around your transaction hash and whatnot, right? In this case, for some reasons, also block hash, right? Where the block header is being hashed using Keshak 256, right? So in this case, what we want to do is first convert our strings to bytes and then hash that value. And so to convert your strings to bytes, we have to use something called abi.encodepacks, right? This is a function provided internally by Solidity to be able to convert stuffs into bytes, right? So in this case, we're going to pass in name, right? So what this is doing is it converts the name into bytes, and once that is provided, it then hash the provided bytes into uh, byte 32. So yesterday we mentioned that this particular hash function returns a byte 32 value by default, right? That's what it does. So when you convert your string into a byte, you expect it to, of course, return a byte. But then to be able to get the comparison, we have to convert it into an hash value or a byte 32 value, right? So the next we want to do is the strict equality sign, which sort of like helps us check if this hash value equals to this hash value, right? We do abi.encodepacks and we pass in name, right? Now there's a difference between this name, which is the function parameter, and this name, which is the state variable in this case, right? That is why we mentioned yesterday that whenever you're passing in a parameter in your function, it's always good to use underscore. It's sort of like a naming convention for passing in your function parameters, right? So now it's not throwing any error because they are two different variables, although they have sort of the same name, right? So because we have to also like state the visibility of this, if it's pure or view. So in this case, this is like a pure function. Okay, I see. Right. So this is going to be a view function because we are reading from the states. Yesterday we mentioned that. And so why this is set to view is because we are reading the value of name from the state, which is this name value or name, what's it called? Yeah, the name value over here, right? Pretty much once we are done, we can now head over to Remix to deploy, right? So when we deploy, we can see comparison, right? So if I try to write just hello, this should return false, right? It returns false because the original name is actually hello Kaia developers, right? So if I pass in this same value, it should return true. So it returns true. So this is how we kind of like work around comparison with what's it called now? With strings, right? Thing to mention also is concatenation, right? Just like in every other uh, programming language, when working with strings, there's a bit of like concatenation, right? You can concat two strings together. But in Solidity, right, there are quite a number of like ways to do this, right? Is it that you also use the ABI encode packs way, or you use the recently updated method on your strings, right? So let's take a look at how to concatenate two strings all together. Let's call this concatenate same string memory name public returns. In this case, we are returning a string. So we say string, we set that data location, and we say return. Now, to use the concatenate method on your string, all you have to do is call the string function or the string keyword dot concatenate. As you can see, it pops up the concat method, which says concatenate an arbitrary number of string of values, right? So we can basically just say concat and we do underscore name, right? So this basically concatenates two strings together. So if you're looking to work with strings in your smart contracts and you need to do certain concatenation or you have to compare, these are like the two major ways to do them, right? So let's redeploy our contracts to the local remix VM. And yeah, so hello Kaia developers. So yeah, we have GM, hello Kaia developers, right? So this is how to concatenate strings in your smart contracts, right? Especially when working with strings. I hope that makes sense. Right, so let's head over back to the course of today, right? I think I did like sort of mentioned the various reference types. And now let's move over to the next part, which is functions, right? Mm, I don't know why this thing is not loading, but yeah. So today we'll be looking at functions, right? Although, we have, all right. So we're looking at functions today, although we have been, going a little bit around them, even prior to this time, how that we've used them to like write deposit functions or even a concatenate function or a compare function just some minutes ago. But in a sense, or in its core, what are functions, right? So I wrote here that functions are like reusable block of code in a contract that helps us perform specific tasks. Now, as you can see from the various instances of how that we have used function, right, it's actually to perform a specific task, either to read from the blockchain state or to mutate the blockchain, right? So there are two things involved. Either you use your functions to query the blockchain or use your function to mutate the blockchain state. And also, you can write a function that accepts payments, which is usually ether, right? And also returns value, just like we have seen in this case, right? And so to declare a function, you have to use the function keyword, right? As we've seen previously, which is now followed by the name of the function and also the visibility and also the return value. And so to write your function, right, we have the function keyword, right? The name of the function, let's say in this case, add, right? And the visibility, let's set this to public, and also the return type, right? Let's call this returns. And you have to pass in the return data type or variable type, right? So this is how to write a function. The function keyword, the name, the visibility. This can be public, this can be internal, external, or private. right? And your returns can take whatever parameter depending on what you want it to return in this case, right? Pretty much it. Once that is out of the way, in this case, when we are trying to write our add function, right, what we are trying to do is we want to add two variables together. Let's say x and what and y, right? So let's do return x plus y. So by reason of this, is there somebody who can what we can also add to this function to make this error go away or this warning go away, right? What do you think we should add? We mentioned that we also have two state interacting variables or keywords that we can add to our functions, right? Um, so it can either be view or pure, right? So we said that a pure function is one that doesn't read from the states and it doesn't write to the states, right? But a view function is one that reads to the states. Awesome. So this is going to be a pure function, right? Awesome. Thank you, Thomas. All right, so this is going to be a pure function and the error disappears. Now, why is this a pure function? Because we are neither reading from the states or writing to the state. We are basically just using the function parameters to do stuff, right? In this case, add two figures together. So that's that about that in this case, right? Moving forward. So we have various function visibilities, right? I think that we must have talked about this. We have public, we have private, internal, and external. And so when we say that a function is public, it means that it can be called by anyone, right? Both externally and also internally. And so when we say that a function is private, it can only be used by, or it can only be called by the contract, meaning that it can only be called by the existing contract or the existing function within that same contract, right? So when we set a function to be internal, it can only be called by the contract, which is the base contract, and also the derived contract or the child contract. So when it comes to smart contracts, there's something called inheritance, which we're going to look at in the next slides, right? So inheritance helps us to um, take various functions, states, or events into other contracts by importing them, right? Or by using the is keyword, right? So in this case, we have a base contract and we also have a derived contract. So a contract that inherits a base contract is a derived contract or a child contract, right? So when you declare a function to be internal in your base contract, once it is inherited in a derived or child contract, right, it can also be accessed by that contract. Now, what's the difference between a private and an internal function? The difference is that a private function cannot be accessed in a derived contract, right? But compared to internal, it can both be accessed by the same function within the base contract and also a derived contract. Now, all of the state variables, all of or by the child contract, literally. Now, another function visibility of in smart contracts is also external, which means that it can only be called from outside the contract. It can only be called from outside the contract. So far, we've looked at four types of function visibility, which is public, private, internal, and external, right? Same thing applies to like state variables or variables in your contract. It can be public, private, internal, and external. Same thing applies to this type of like variables. But by default, every variable declared in your contracts are by default internal, right? So if you declare a variable in your smart contract, so let's say we declare a variable here, right? Without adding a visibility, right? Owner. So this function is by default internal, or sorry, this variable is by default internal, meaning it can only be accessed by the functions here and any other derived contract. So any contract that is, let's say we write another contract called inherit, inherit owner. And so we do something like is reference. So this address owner can only be used here in this contract and this contract that derives the reference contract. So yeah, that brings us to the fact that any variable declared in your contract by default, its default state is, or its default visibility is internal, right? We have to keep that at the back of our mind. And for when it comes to state variables, right, whether they be internal, external, public, or private, right, they can still be accessed on the blockchain. Now, the concept of visibility is only true in contract instances or function instances. Now, what do I mean? When we say variables to be public, private, external, or internal, it's only in the context of the contract when they are interacting with each other. But in the context of the blockchain, everything can be accessed, whether it be private, whether it be external, whether it be internal, or whether it be external or public, right? Everything is still accessed on the blockchain, right? I hope that makes sense. Moving forward, um, yeah. So moving forward, we already talked about this, view and pure, right? Can read blockchain state but not modify it. We also have pure, can neither read or modify blockchain state. Now we also have a function that is payable. Now when we say that a function is payable, it means that it can accept Ether, right? And so because Solidity is like the programming language for writing smart contracts, and the legacy blockchain for EVM is Ethereum. So by default, um, we have representation in Ether in Solidity. But when you're working on Kaia, it means that because Kaia is EVM compatible, it means that when you write a function to be payable, it means that that function can also accept Kaia because Kaia is the native token of the Kaia blockchain, right? So let's quickly demo what a payable function looks like. All right, I think we have one, but we did not set it to be payable. So our deposit function just takes in address, address, and uint val. But in this case, we are manually just passing in a number, right? Or an integer. But let's pass in value, right? So how do we change this function to accept Ether? So what we can do is we declare function, we set this to deposits, and we call, we set the visibility, and we say it is payable, right? So when we declare that this is payable, it means that when this contract or when this function is executing, it can accept Ether along with itself, right? And so what we can do is we can now update the mappings of balance, msg.sender plus equals msg.value, right? And so don't worry if this is new to you, msg.sender or msg.value. These are global variable available to us or provided to us by Solidity, right? msg.sender means the person executing this contract in this context, while msg.value basically is the way value that is being sent when executing this function, right? Let's take a look at how this works, right? Let's redeploy our contract, in this case, reference. Right. So as you can see, we have a function that is colored red, right? this is because it's a payable function, right? It's colored red because it's a payable function. What we have to do here is we have to send in money, right? Because it's a deposit function. We are trying to write like a bank smart contract where you can deposit value. And so to do that, if you go over to Remix, you are going to see different fields. You see the account, and an account has up to 99 Ether, right? 100 Ether, and whatnot. So these are like test accounts that you can use to test various scenarios for or in your smart contract, right? So what we want to do is to send in value to this smart contract. And to do that, we are just going to change the representation over here, right? So in a later slide, I think I'm still going to talk about various representations of ether units. We have Wei, we have Gui, we have ether, right? And what each of these things mean. But bear it in mind that ether is the whole representation of um, your Wei, right? So Wei is like the smallest unit of ether, which means that it's just a literal number. So one Wei equals one literal number, and one ether equals 1 times 10 raised to power 18, right? So I think I'm still going to like explain in, yes, units of ether. So this is basically ether units, right? In Solidity, we have various units. We have time units. We have ether units, right? So ether has sort of some sub-denomination, right? Just like how we have dollar and cents, we have naira and kobo, right? Depending on whatever nation that you are, right? But I think the most popular one is dollar and cents, right? Um, in this case, you can represent the dollar value in various sub denominations. And so the ether value for, or like the ether has various sub denominations, and it can be Wei, Gui, Fine, and the highest in that is most popularly used is ether, right? So pretty much what we want to do here is to set the value of, okay, we have another question. Okay, yes, yes, yes. Um, moving on. So what I want to do here is to set the value of ether that we want to pass into our deposit function, right? So when I click deposit, I expect that I should have deposited 1 ether. And when I try to check my balance, it should return 1 times 10 raised to power 18, right? So as you can see, we have 1 with 18 zeros, right? So this was what I was saying the other time, right? We have 1 with 18 zeros. If you count this, this is like 18 zeros because on the blockchain, it is represented as Wei, right? Every every unit is represented in their sub-denomination, right? Ether is represented in its sub-denomination, which is Wei, right? And 1 ether is 1 times 10 raised to power 18, right? So that's why when you sent 1 ether over, when we sent 1 ether here, it gave us 1 times 10 raised to power 18, which is this value over here. Pretty much, right? And so this is how you use payable in your function, right? It is used whenever you want your function to accept ether, right? Probably you're writing a token smart contract and you want people to pay, or an NFT smart contract, and you want people to send in money to mint an NFT before they get to get the NFT. You have to declare your mint function to be payable, right? In this case also you can set certain preconditions, right? On probably you need the deposit value to be greater than 1 ether, or your mint value should be greater than 10 ETH, right? Depending on the price of your NFT at the time. It depends on the logic you're trying to like encode in your smart contract, right? Moving forward, that's all about payable function. The next on the list is function modifiers, right? So what are function modifiers, right? Function modifiers in this case are basically uh, are basically used to like check for certain preconditions before your function is being executed. Bless me. Before your function is being executed. What this means is that there are certain times where you need to check for certain preconditions or prerequisites when you're working with your function. So your modifier is one of like the major provisions in Solidity to help you check for certain preconditions before functions are being executed. Now, I can list, not one, not two scenarios where you want to check for certain preconditions. I think I already mentioned in the case of where you want to mint an NFT, right? You can say that you want the MSG of value, which is the amount of money that you're passing into your function, should be greater than either 10 ETH or 5 ETH at a time. This is a certain precondition. And so we can encode this precondition in modifiers. You can also say that, oh, before somebody mints a particular token, or before you deposit, you have to be part of the whitelisted addresses, right? You can set up a modifier for that before you sort of like, oh, mint the token, you must have been whitelisted, right? And that means that you have to set up a modifier in this case that whitelist address each time, or that checks if an address has been whitelisted. If the address has not been whitelisted, the function throws an error, right? So this is like the essence of a function modifier. In simple terms, a function modifier can be used to change the behavior of a function in a declarative way. That's like the theoretical definition of it. But in practice, it's it's basically checking for a certain preconditions before your function is being run or executed. I hope that makes sense. Now, how do we declare function modifiers, right? So the way to declare function modifiers, just like every other type of like stuff in Solidity, it has certain keywords, right? So one of the keyword or the keyword for declaring modifiers is to use the modifier keyword, right? Once you are done with the modifier keyword, then the name of the modifier and also your curly braces, right? So let's take a look at this in practice, right? How do we declare our modifier? Let me cancel this contract. So like I mentioned, you have to declare the modifier keyword, right? The name of the modifier, the most popularly used modifier is only owner, right? You must have seen this for people who, have either studied ahead or have interacted with smart contracts one way or the other in the past, right? And for the sake of those who are sort of like new, modifier or like the only owner modifier is one of like the most used modifier when it comes to smart contract development, right? It's basically used for access control um, while developing smart contracts. There are some functions that you don't want people to access or you don't want people to call. Your only owner is what gives you that access control such that only the owner of the contract or the deployer of the contract can do certain things, right? This is how it works. It's just like how that um, certain people can't do certain things in government, right? Except like the president approves all that has been done or all that has been, said or placed to be done. Except that the president approves it, it doesn't work until the president approves it, right? So this is the case of the only owner, sort of like an access control to ensure that your function should run as what's the word now? As planned to run, right? So once you've used the modifier keyword and the name of your modifier, the next part is the curly braces. Then now this is where you write your precondition, right? One of the ways to write like one of the ways to check for certain conditions in Solidity is to use the require keyword, right? Or to use if statements, right? The major or the most popular one is to use require, right? Because it provides you the functionality to write your condition and also throw an error at the end of the day, right? The reason why the condition is failing in this case. So what we want to do is we want to first declare an owner. I think we have an owner already, which is this guy, right? Now let's set it to public and it's no longer internal. And so we have an owner. So let's also set a constructor, right? Like I mentioned yesterday, a constructor is a function that runs once while you are initiating your contract, right? It's basically used to like initialize your contract functionality. And just like in this case, we are trying to initialize our owner, right? And we can pass in address owner, or leave it to be empty and just say that owner equals msg.sender, right? So in this case, this is like the person initiating the transaction. And so usually your constructor would run at deployment, right? It's the first function that will be executed at deployment. So whosoever is calling or whosoever is deploying the contract becomes the msg.sender, which in turn becomes the owner, right? And so we have sort of like in a way initialize our contracts, right? It speaks to the fact that your constructor is that function that sort of helps you to like initialize your contract variables, right? If you agree with me, right? As we can see right now, this is what we have used our constructor to do to initialize the state variable in our contracts at deployments. Okay, so moving forward, the next thing we want to do is now that we have our owner initialized, we want to check. Now, the purpose of writing the only owner modifier, like I mentioned, is that we we want to use this modifier in our functions such that only the deployer of those contracts or only the owner can do certain things, right? So of course, we want to check if msg.sender, meaning that whosoever is calling the function at the time, equals to owner, right? If it's not equals to owner, we want to throw an error message. Let's say not the owner, right? So this is going to throw an error if msg.sender does not equals to the owner that was set in the constructor over here, right? And so the next thing to note when declaring a modifier is this special character underscore and semicolon. Now, what this means is that for whatever function that uses our modifier, the function is being passed here after this line 100 is executed, right? In simple terms, it means that our function is passed here when line 100 is executed. Now, let's write a function. Somebody should give me an idea of a function that we can write. Anybody? Anybody? What type of function can we write for our Oleuna to use an Oleuna? We currently have deposits. Okay, let's write a withdraw function. Function withdraw, right? And let's set this to public. And so now using our Oleuna, we have to set Oleuna. Now we've declared the instance of our modifier. Now this is us using our Oleuna, right? And we want to do msg.sender, or let's pass in address to and do to.call value. So let's get the value of smart contract. In this case, let's do address this dot balance and passing this value over here. And what we do, all right, so just to run us through, this is a withdraw function which uses the only owner modifier, right? Basically, just like how we were writing our deposit function, right? Anybody can deposit into the smart contract, but just know how person can withdraw the money because now it involves funds, right? This is like the use case for our smart contract. Now, to do that, we need to set in an access control, and that's why we are writing a modifier that checks if whosoever that is calling the withdraw is equals to owner, then run the function over here, right? If whosoever that is calling message of sender does not equals owner, throw this error reference not the owner, right? So what is line 104 to line 107 doing? It's basically taking an address to, which this is the address where we'll be sending money to, and we are getting the current balance of this smart contract. We are saying address this, right? This particular smart contract, how much is in this address? Then we are using the call, the low level call method to basically send the balance of this smart contract to this address to. And because this low level call sort of like returns Boolean, we have to check if the transaction actually went through, right? And so this is what we sort of like did in 107. Okay, so let's see our only modifier, the only owner modifier in practice. If we try to first redeploy, let's check our current owner. Our current owner is OX5BC4, which is this first address, OX5BC4. And this is because this is the account that sort of like interacted or that deployed the contract at execution, right? And so what that means is when we deployed our contract, right, the constructor was executed and it sets owner to msg.sender, which is this account over here that is running the transaction, right? Or that is executing the transaction. Now, the next thing we want to do is we want to deposit funds, right? Now let's use another account to deposit funds. Let's switch to account 2, right? Let's pass in some value and let's hit the deposit value or deposit function. If we try to check, as you can see, the contract now has one hit, right? This is the current value in our smart contract. Let's try to deploy or send more value into the smart contract by switching to the third account, right? Now let's deposit once more. Now our contract has 2 hits at a time. Now to use the withdraw function, now mind you, we mentioned that the withdraw function is meant to only be executed by the only owner, which we declared in our modifier over here. Just to recap, a modifier is used to change the behavior of a function or used to set certain preconditions before a function is being executed. Just to restate that, right? That's what a modifier actually does. That's the major functionality of a modifier. Now let's see if our modifier would actually check for certain preconditions before it withdraws. Now, the precondition that we have set for our only owner is that the person calling the withdraw function has to be the owner that has been set at deployment, which should be 0x5b C4. Now, let's try to change our contract to account 4 and call withdraw, right? Let me copy an address. Let me copy the same address. And so, as you can see, it throws an error saying that reference.withdraw errored, error occurred, revert. Now, it says that the transaction has been reverted to initial states, reason provided by the contract, reference, not the what, the owner. So what the only owner modifier did was, because it has been added here, right, and in line on 101, there is this special symbol over here. When we run this function, it goes over to only owner and checks this line 100. If it's true, then this function executes. This is what this line does. Then if it's false, it throws the error reference, not the owner, which was exactly what it did, right? So if we try to switch back to the only owner and we transact, so as you can see, it was successful, right? Compared to the previous time, which it failed. And so if we try to check the balance of the contract, it's now 0, right? Previously, we had 3 hits in the smart contract. Yeah, and as you can see, the value of OX787 increased, right? Because that was the value we provided in our withdraw function, OX78AB, right? So that's pretty much about only owner, right? How that they help us check for certain preconditions before our functions are being executed, right? Pretty much moving forward, we have inheritance. And so far, do we have any question? Oh, cool. Do we have any questions so far? Do we have any questions so far? If we have any question, please let's put it in the chat, right? And yep. Yes, the modifiers are checked, right? This sort of acts like, oh, the watchman to like help you check for certain preconditions, right? Before your function is executed. That's basically what they do in this case, right? All right. So let's go to the next part, which is inheritance, right? Just like every other programming language, right? We can inherit smart contracts, or like a particular smart contract can inherit another smart contract. Now, what this means is that you can basically inherit the function, the event, all of the state variables that exist in a particular contract becomes existent in the derived contract, right? So when we are talking about inheritance in Solidity, you can inherit as many or as much as more contracts that you want in a particular base contract. So a base contract can have multiple inheritance. So you can do something like contract A is B and is C, comma C, right? This is multiple inheritance. So how do we do inheritance in Solidity? We do inheritance in Solidity by just using the is keyword, right? What this means is you specify the contract and the name by default, then you use the is keyword and the name of the contract you want it to inherit. Now, when it comes to inheritance, 2 things are involved. We have a base contract and a derived contract. I think I talked about this in the previous, slides, right? We have the base contract and we also have the derived contract. A base contract is a contract that has all of the functionalities that has been written, both the state variables and the functions and whatever property or method And the derived contract is the one inheriting the base contract, right? So this means that the derived contract will be the one that uses the is keyword, right, in its contract setup. Now, when it comes to inheritance, we need to also understand two things also, that a function that is going to be overriding in a child contract needs to be declared as virtual. What this means is that if there is a function that you want to override, meaning that you want to change whatever functionality that exists in that function in the base contract, in the child contract, from the base contract, you have to specify that it's a virtual contract, right? You have to put it as part of the keyword in the function specification, right? Same thing applies the um, for the function that is going to override a parent function, right? So for a function that is going to override a parent function, this is majorly in the child contract or the derived contract. You have to use the override keyword. Now, so these are two like spectrums of various use cases, right? What a virtual keyword does is that if you're going to override, if a particular function in your base contract is going to be overridden by a child contract, meaning you're going to change the functionality in your child contract, you have to specify in your base contract that that function is virtual, right? In simple terms, that's what virtual keyword does, right? And if a function that is going to override a parent function in the child contract needs to be specified, you need to, or needs to be used, you have to specify the override keyword. Now, all of these things are just theory. Let's look at them in practical. Um, I think we've written quite a number of like examples in the reference contract. Uh, mm. So what we can do now is we can write a new one called contracts, and we name this complex. So this is the first step, right? I mentioned that, you know, the first step to inheriting contracts is using the is keyword. So to inherit reference, which is this contract, all we need to do is use the is keyword and the name of the contract, reference, right? So now, if I try to uh, so I have just deployed complex, and um, all of the values, all of the variables, all of the function in reference exists in complex, right? And so uh, this is like the idea behind inheritance, right? Where, you know, sometimes you might want to reuse codes in certain contracts, and you don't want to write that same code all over again. Now, this is where inheritance comes in, right? Inheritance basically helps us for code reusability. In the case where we have like complex smart contract patterns or systems, right? Sometimes we don't want to rewrite code from scratch, and what we have to do is just inherit that same functionality in a new contract that we're trying to use it. And if there's a need to like let's say override, right, we can override the functionality. Now, this is where override and virtual comes in, right? There are some times where probably the function that have been written in your, let's call this derived contract. Oh, sorry, this is the base contract. And this is derived contract or child contract. Uh, Now, if for some reason there's a function in my reference contract that I need to, so let's call this function sub, right? Yep, let's pass in uint x. Let's call this multiply instead. Uint y public returns uint return x times y. All right, so we have written a simple uh, multiplication um, function over here. Now let's take a look at how to make this uh, overriding, right? Now, the way to do that, if in the case where I want to change this to a separate functionality in my derived contract, right? What I have to do is I just have to set it as virtual, right? So this means that any function that is calling this, that wants to override this, must set the override keyword. Now, so if I want to if I want to rewrite this in my complex smart contracts, I just need to use override. And as you can see, the error is gone, right? I can change this to plus. So this is me basically um, using the same function from my base contract, but I'm overriding the functionality, right? I hope that makes sense. In my base contract, I did set it to virtual because my child contract function is going to override the functionality. And that's why when I'm using it in my child contract, I basically set it to override. If I leave this to virtual, it's going to throw an error, right? Because it currently exists in my base contract. So I have to set it to override, right? And change the functionality, basically. So that's that about inheritance and solidity. Um, we've talked about how to do inheritance in Solidity using the is keyword, and also how that you can use virtual and also override. And in most cases also we have multiple inheritances where I can write another contract over here. Let's call it dynamic. And it's sort of like inherit reference and also complex, right? So this is what we call multiple inheritance, right? And also while I'm trying to, so let me quickly break this down. I'm setting this to virtual because in my other derived contracts, I'm also going to override the functionality. So the same logic applies, right? Whenever a function needs to be overridden in a child contract, you have to set it as virtual. So because I need to override it in my dynamic contract, other than setting override, I set it to overriding, also, sorry, to virtual, right? Such that when I want to override it in my child contract, I can use the override keyword. And now because this is multiple inheritance, I have to set the contract that I need it to override. So in this case, the reference and also the complex contracts, right? So that's that about inheritance and also multiple inheritance in this case. The list goes on and on. Yeah, so over to like units in Solidity. I think this is a part where I was mentioning the other time, right? Where we have both eta units and also time units. So when it comes to Solidity, right, we have something called literal numbers, which is basically just like one, right? So we have literal numbers, we have units, we have literal numbers, sort of like your integers, right? Like one, the way we have 1, 2, 3, 4, 5. So we have literal numbers. And some of like the literal numbers have sort of like some suffix in Solidity. So when it comes to eta units, right, which means how that eta is represented in Solidity, we have one eta, right? We have one way. We have one way. So these are like representation of eta units, right? And we say that we said in the last session that one eta equals one E18, and one way equals one, and one way equals one E, 1 times 10 raised to the power 9, right? 1 E9. So just like we showed in our previous deposit smart contract implementation, how that we sent in one ether over here, and when we were trying to call our deposits or our get balance, so when we try to call our get balance, it shows 1 times 10 raised to the power 18, right? Because this is how like ether units are represented on the blockchain. So if we bring this over here, we can calculate how much was sent. Now to do that, you can head over to Kaia toolkit.kaia.io, right? And go to utility and go to converter. You can basically just paste in the wave value and it returns the Kaia value, right? So this is the wave value and this is the Kaia value. If I change this to the same value with additional zeros, that means I have 100 Kaia. If I add more zeros, that means I have 10,000 Kaia. So when you're trying to represent 10,000 Kaia, you have to pass in 10,000 times 10 raised to the power 18, which is the representation in way, right? So that's like the explanation for ether units. Most of the times you would switch in between ether and way, right? So for you to be able to do some of your conversion, sometimes you might be working with Kaia, maybe you want to send 0.001, right? Or you want to send 0.005. So you just copy this value and go over here, switch your value back to way and paste the value here, right? So this is the way value that you want to send in for 0.005 Kaia in this case, right? I hope that makes sense. Yeah, that's pretty much for the ether units. So we also have something called time units, right? We have ether units. We also have time units. We also have time units. Now, like I mentioned, we have scenarios of literal numbers being represented with or given suffixes. When we say suffix, we mean that you have like a keyword at the end of the literal number. In this case, we have 1 then eta at the end of 1, right? So for time units also, we have various subdenominations of time represented in Solidity. We have days, we have seconds, we have minutes, and so on and so forth. So we can do 1 day, right? We can do 2 days. We can do 1 minute. We can do 60 minutes. And so these are represented in seconds, right? So just like to go over what this means, right? One literal number in time unit equals 1 seconds. Just like every other normal time calculation, right? 1 minute is 60 seconds, 1 hour is of course 60 minutes, and 1 day is 24 hours, and 1 week is 7 days. So this is like the calculation for the various time units that we have in Solidity. Now, how do we sort of like use those time units, right? For quite a number of applications, you might have scenarios where you lock up funds and people can only claim these funds when the lockup period is sort of like complete, right? And how do we calculate the time from when they locked their funds up to the time where they want their funds to be locked? So this is where we use time units, right? There are scenarios such as token vesting and all of those things where people vest their tokens for a certain period of time. And so this is where your time units comes into play to sort of help you calculate the days, the time, or the minutes for the lockup period that you are looking to work with. And so once the lockup period is like sort of like met, then you can do whatever thing you want to do. So you can write functions such as, oh, if like the lockup period have elapsed, then you can transfer so tokens to so person, right? So these are like scenarios of how you can use time units in your contracts, right? Moving on, we have global variables, right? I think I've talked about quite a number of global variables already. So global variables are those variables and function that can be called or can be used globally within your smart contracts. An example is msg.sender, right? msg.value. These are not variables that we state or that you state yourself, like address or strings or mappings. They are provided by default globally in Solidity for certain scenarios or for certain reasons. Take, for instance, msg.value is meant to be the representation of the way value sent when you're executing a particular function in your smart contract, right? msg.sender is the person currently executing the function in the instance of the transaction call, right? So let's take a look at some type of global variable, right? Or the various global variables that we have. All right, so we have, these are quite a number of like variables that you're going to be seeing or you can use in your smart contracts. Yeah, so we have block hash, right? What is your block hash? Your block hash is the hash of a given block. When block number is one of the 256 most recent block. So just to cut the long story short for block hash is that a block hash takes in a block number and it returns the block hash. But when you're trying to get the block hash, you can't get a block hash for a block number that is not part of the most recent 256 block. Now, if you are trying to get a block hash for a block number that is more than the most recent 256 block, it's going to return 0. Now, the reason for this is for scalability issues, right? Because of course you can't start reading through tons of millions of block number in that has been validated and added to the blockchain and wanting to get all of this within your smart contract. This is like a lot of data to keep up to, right? So that's why your block hash only returns the block number for the most recent 256 block, right? And if you pass in one that is not most recent, it returns 0. Now we also have block.base fee, which basically returns the current block base fee. The base fee is basically the minimum value that is required, or the minimum gas fee that is required for a transaction to be added to the block, right? So this is what block.base fee is. When we talk about block.chain ID, it basically returns the chain ID of the chain. Now for Kaia mainnet, it is 8217. This is the chain ID of Kaia mainnet. For Kaia Kairos testnet, it is 1001, right? Now it's basically for you to know the current blockchain which you are currently working on in your smart contract. Take, for instance, I think there was a time I was implementing a cross-chain contract using layer 0, right? And because layer 0 uses some sort of like endpoints connection between each contract, we had to check if I'm currently on Kaia. And if I'm currently on Kaia, I should be able to delegate call to another blockchain, say Base or say Ethereum, right? So block.chain ID sort of like helps you to like get the current chain ID, bless me, which you are working on, right? That's the blockchain ID, right? The next part is block.coinbase. In this case, block.coinbase returns the current block miner's address, or the validator address in this case. Now, moving on, we also have block.gas limits. Your block.gas limits helps you returns the total amount of gas that can be used up in a particular block, right? Now, gas limits is how you know the number of transactions that can be fit into a particular block, because it returns the total amount of gas that a particular block can actually have, right? So most of the time, developers use this block.gas limits to actually know how many transactions can be fit into a particular block, right? We also have block number, which is block.number, the current block number. We have block.timestamp, which is the current timestamp as seconds, or like the current block timestamp in seconds since Unix epoch, right? In this case, most of the time we use block.timestamp to sort of like do lockup periods, right? Check for when a particular person actually interacted with a particular function or smart contract. Basically just trying to use block.timestamp as time units in your smart contract. We also have like gas left, which basically returns the remaining gas, msg.data. Now, for msg.data, I think is more like a very, very important one, because it contains the function signature and also function selector, right? In this case, a function signature is basically the function name and the function argument type, right? That is the function signature, right? Why the function selector is the hash of the first is the hash of the first 4 bytes of the function signature, right? So msg.data in a complete sense is basically the transaction or the function name and also the function argument. Now, when you call a particular function under the hood, Solidity sort of like check for the function name and for the function arguments. This is how it sort of like identify, especially when you're doing contract to contract interaction. This is how it sort of like knows what function to call or what function not to call, right? msg.sender also returns the current sender of the message, like I mentioned. The person that is currently initiating the transaction during the transaction call or at the time of the transaction call. We have msg.sig, which is the first 4 bytes of the call data, which is also called function selector, right? Like I mentioned previously. Now, msg.value is the number of way, which is sent with the transaction call. Now, sometimes, as you see, or as you have seen, when we called the deposit function, and in our deposit function, we used the value msg.value, or we used the keyword msg.value. What that is telling us is that we should also, what that is telling us is that we should take the number of way that is sent into the smart contract at the time, right? We should take note of the number of way that is sent with the function deposits at the time that we called it. And because the function deposit is payable, and in our remix front end, we are sending one it. So it's going to basically take that one it that we are sending and use that as msg.value, because that's the number of way that has been sent with the message or with the transaction call, right? tx.gas price is basically the gas price of the transaction, right, at the time. And tx.origin is basically the sender of the transaction, the full chain call. And when we say full chain call, what it means is, so if you have 3 contracts, right, and in contract A, you are using something like tx.origin, right? So you have another contract, contract B, you have another contract, contract C. Now, contract A calls contract B, and contract B calls contract C. Now, to contract C, contract B is the msg.sender, but contract A is the tx.origin, because this is the initial sender of the transaction. Now, if contract A calls contract B and contract B calls contract C, contract B is the msg.sender to contract C, and contract A is the tx.origin for contract C, meaning that it is the full chain call, where the original call originated from in this case, and where the call originated from by default is from contract A. So contract A is the tx.origin. Now, one of the things to note for tx.origin is that this should not be used when you're trying to authorize people for certain access control, right? It can be used for some sort of phishing attacks, right? In your smart contract or generally. So yeah, that's pretty much about global variables and whatnot in Solidity. I think quite a number of it that you'll be using, or quite a number of the variables that you'll be using, is actually msg.value, msg.sender, block.timestamp, and also yeah, yes, and block.timestamp, right? Pretty much those 4, right? Yeah, so do we have any question before we go to the next part? Any question? Do we have any question? Okay, so just to confirm, awesome. Thanks, Johnson. What do we understand by block.timestamp? Or somebody else, msg.value, right? Anybody who wants to try? Do we have anyone who wants to tell us what msg.value is, or block.timestamp? Do we have anybody? Okay, yep. Awesome. MSG of value is the amount of way initiated during the transaction call. right? Pretty much. Yep. So how about block dot timestamp, right? Anybody? All right, thank you very much, David. Right. I think that for most of us, right, we have we been following along, just to confirm. Have we been following along? Awesome, awesome. All right. So moving forward, we have the handling of errors in Solidity. Just like you know, we have quite a number of just like every other programming language, right? You might need to handle errors within your smart contracts, and probably when you're trying to send a transaction, and you need to, check for instances of error. Now, there are various ways to, handle errors in Solidity, right? But before we jump right in, we have to note that any error that is being thrown will undo all changes made to the state during a transaction. So if you are trying to deposit and it basically throws an error, what that means is that your intention to actually change the balance mappings, which is the balance state variable, would revert. So that means that it's going to undo the changes. So if in the case of you wanting to send 0.5 Kaia and the smart contract requires you to have 1 Kaia, right? That means that if there is an error handling, or if there is an error, your intention to deposit 0.5 will not go through. So it undoes, it basically just undo all of the changes made to the states during the transaction. Now, what are the various ways to throw an error in Solidity? Now, we have three major ways: by using the require statement, and also, or by using the require function, the revert statement, and also assert. Now, what's the difference between require statement, revert, and also assert? Now, your require statement is used to validate inputs and conditions before execution. Now, what that means is you basically use your require statement most times where in your function, you need to validate an input. Take, for instance, in my function or in my deposit function, I want to pass in an amount. And the requirement is that whosoever needs to deposit must deposit greater than 1 Kaia. So my require statement is used to validate whatever input is coming into that function at the time. If it is actually greater than 1 Kaia, then if it's not, it should throw an error, right? I think we did that in one of the examples when we were trying to write the deposit function, where when the deposit, or sorry, not the deposit, the only owner, right? If it's not the owner, then throw an error, not the owner, right? So this is one of the ways to undo errors in Solidity. Your require statement is used to validate inputs and conditions before execution, right? Revert is sort of like similar to require also, right? Used to validate, in this case, we use it with if statements, right? Once you are done with your validation using your if statements, you basically just throw revert, right? Also, we have assert. Your assert keyword or your assert, your assert keyword is used to check for code that should never be false. Now there are some constant, there might be some constant parameters that need to exist in your contract, right? So your assert keyword is basically used to check for scenarios that needs to be true at all times. Now, take for instance, um, one ether would always be 1 times 10 raised to power 18 at all times, right? That's like the standard. One way will always be 1 by default, and one GUI will always be 1 times 10 raised to power 9. Now, this is where asserts would come in. If you have scenarios or instances of where you need to check for um, conditions that needs to be true at all time throughout the life cycle of your contract or whatnot, this is where you use asserts, right? Now we can use asserts when we are trying to check if a particular constant value is the same that is being passed, right? In this case, that 1 ether equals 1 times 10 raised to the power 18, or 1 way equals 1, or that 1 gray equals 1 times 10 raised to the power 9, right? I hope that makes sense, right? Moving on, I think I've just explained all of this. Yeah, pretty much it. This is how you basically use assert, require, and there are like 2 variations of require, one with condition and without the error message. And there's one with also condition with error message. Now, the one that we have used in the code is the one with condition and error message. I think it just makes sense to use the one with the condition and the error message such that, the users or whosoever is interacting with your smart contracts can know the cause of the error. And also, we also have the revert without error message, and we have the revert with error message, right? So these are like major 3 ways or like 4 ways of using these various keywords. Now we also have something called custom errors, right? Custom errors like are a more efficient ways of like handling errors, right? Or customizing errors in your smart contracts, right? So the way this works is by using the error keyword, the name of your error, and passing in the various values of the various value of what you want it to show. Now, in this case, there are certain scenarios where you might want to throw an error. Take, for instance, for require. Um, require doesn't have a detailed way of you telling the user what actually happened that the transaction failed. Now, it only helps you put in an error message. Take, for instance, not enough funds, right? So it sort of like tells the user that, oh, it doesn't have enough funds. How about there's a scenario where you can customize what value you need to show to your users such that they can have more informed uh, knowledge as to why their transaction failed, right? So let's see a practical example of custom errors, right? Let's go back to our deposit function. Yeah, this one. And mm, let's sort of like modify this, right? So what we want to do is in our errors, so I use the error keyword, the name of the error, invalid or insufficient balance. Then we pass in the various data types or variable types that we want to display to our users, right? We want to display the amount. I want to display the address, right? So in my deposit function, I think, yeah, it's over here. I want to write a require statement that says that MSG whose value should be greater than or equals to 1 ether, right? And that's basically the condition, right? And so we are trying to use a require statement that has condition and also an error message. So one way to do this is to pass in an error message saying deposit uh, invalid amount, right? That's one way to do that. But another way to do that is to outrightly pass in the custom error over here and say, what's the name again? Insufficient or invalid amounts. Insufficient amounts, right? Insufficient amounts, and we pass in msg.value and msg.sender, right? So this is how we use our custom error, basically. Our custom error, we can both use it in the revert and also the require statement. Also, our require statement, we can choose to pass in a string instead of a custom error over here, right? We can, just like I showed the other time. And so this sort of like provides a more detailed reason why the transaction failed. So let's sort of deploy this transaction one more time. Oh, sorry, the contract again. And yeah, when I try to so when I try to deposit 1 ether, this should pass through, right? Because of course, MSD of value is greater than or equals to 1 ether. Now let me switch my account back to another account and pass in, let me switch this to way, and let me set it to 5, whatever, right? And try to call this function. As you can see, it reverts and it says that um, the transaction has been reverted to initial state, error provided by the contract, insufficient amount. The amount is this 500,000 way, and the value is the MSC of value. So it sort of like provides more context to why your transaction failed. So now you know that, oh, your transaction failed because you passed in an insufficient amount, in this case, which is this guy. Pretty much it. If we want to make it more detailed, right, I can choose to pass in another variable here and say that uint allowed amount, and in my error here, I basically just pass in one ether, right? Such that when I redeploy this contract, I basically can now deploy, right? So let me try to pass in 500 by default from here, 500 way, right? It basically just throws, an error, insufficient amount. This is the amount that I passed in, 500 way, and this is the address that I used to interact. But the allowed amount is 1 times 10 raised to power 18, which is 1 ether and above, right? So I can basically just deduce from here that, oh, I basically have to send in, 1 ether and above. And if I, of course, send in 1 ether, it should pass. And so this is like one of the ways to basically use custom errors in your smart contract. Yeah, so far today, we've been able to look at various items from, you know, um, yeah, from functions to, we started with strings, then we moved on to functions, how to use functions, um, the various function visibility that we have, right, from public to private to internal to external. We also talked about various, state changing visibility or interaction keywords like view and pure. Then we also talked about payable function, right? Function modifiers, how that this basically helps you change the behavior of your function, and inheritance, and also like ether units, right? In this case, we explained and explored various ether units from way to ether, and we also looked at time units from 1 seconds to like days in this case. Global variable that is being provided to us by Solidity, right? We explored all of these ones also. MSD.sender, MSD.value, block.timestamp, block hash, quite a number of all of these global variables, right? And also error handling in Solidity. So I think that'll be all for today. Tomorrow, we'll be looking at digital assets and tokens, right? So I think we have come to the end of today's class. Do we have any question? Okay. Also, the modifier for only owner. All right. What is it about that? Just to confirm. Yeah. So, yeah, I think a PDF for study. Okay. I think we are going to share that after the session. Do keep an eye on the Discord channel. So yeah, for sure.
Yeah,
So do we
absolutely.
have any question?
Yeah, any questions? If anyone is also brave enough to ask a question live, like they only wish to raise their hand and ask a question, that's fine as well. Otherwise, like as always, this session is recorded. Oh yeah, Ayo, no task today?
Yeah, so there's no task for today. I've not gotten any submission from yesterday's task anyways. But the deadline is on Friday. Really looking for what you guys are going to like do. Yeah, there's a repo already. Thank you, Samson. You can go to build on Kaia Bootcamp on KaiaChain.org, and you're going to basically just see all of the repo, all of the folders for each week, and the sample codes that were explained in each session. And so pretty much it. You can also find it on Discord, right? Just go to the general. I think I shared it yesterday, if I'm not wrong. Yes.
It's okay. I
And
think
yeah,
what I will
pretty
do
much it.
is I will collate all the links and then share it. We have a separate channel for bootcamp files. I know it might be a bit
Mhm.
confusing, but I think we'll put everything there, just for consistency's sake. All your setup documentation, everything will go there, in addition to the PDF. Yeah, so do
Mm.
give me a bit of time to sort everything out, um, because as I mentioned, it is quite late already. It's almost 11 o'clock where I am. So do give me a bit of time, and we all have to work tomorrow as well. So yeah, just give me a bit of time. It should all be up by tomorrow latest. And yeah, so the next a bit of housekeeping as well. The next lesson, lesson 5, will be held on Thursday at the same time, 2 p.m. West African time, 9 p.m. Singapore, 10 p.m. KST. The Zoom link should have already been sent out to you. If they're not, please do message in Discord saying, "Hey, I didn't receive anything." Just putting it out there. For those that, if you still encounter issues with Discord, then I would say the best case scenario for you is just email back the email that is, because I think everyone has received a newsletter email, right? Similar, oh, lesson 3 is happening, lesson 2 is happening, or so on and so forth. So your best case scenario is if you have any issues with Discord, please do email dev@kaia.io. I think the email is also in the Zoom sent email. Yes, my question is on the assignments. We have a question. Okay. My question is on the assignment on Kaia scan on the event logs. Because after deploying an interaction, the event logs is not open. Please, do we need to verify the contract on Kaia scan?
Oh, no, you don't have to verify. I think you just once you deploy, right, there is an event log tab that basically opens up for you. where you get to, and this is after you've called the set class function. So it basically opens up for you when you call the set class function because there is an event in the contract which is being emitted, right? Yeah, exactly. You have to call the set class function first.
My question before you can see the event, I think Samson is still typing. How can we get feedback on our assignments?
Oh, awesome. I think I'll do that once I kind of like grade. So we're going to grade the assignments internally and share um, based on how you guys did, right? On Discord. So yeah, I think myself, Sean, and the rest of the team will grade you guys' assignment and get back to you guys on that.
Yeah, so I think the forms also have their emails attached, right? You have to submit your email in addition to the form. So yeah, we will
Mhm.
contact, I think we'll also contact everyone. We'll also let everyone know on Discord that hey, we've done the evaluation. Please check your emails as usual. Yeah, just as another level of hey, because sometimes emails do get lost and sometimes they do get sent to spam. Which I think was the case, I think, for some of the participants. Very strong email filters you guys have, so fantastic. A bit too strong. But anyways, yeah, so I do hope that everyone does get the emails. If they're not getting the emails, as I mentioned, please just email Kaia, dev@kaia.io, for the best case scenario, because you, if you're not in the Discord, I think honestly the first line of response should be messaging in Discord. But if you're not in the Discord, then you just email the email that we sent you. Yeah, okay. Ah, yes, thank you, Eric. Yeah, just email that email in the bottom corner, or bottom corner of my screen rather, or in the webinar chat. Yeah. So any further questions, please just chat away on Discord. We will try to respond as quick as possible. We also have our ambassadors who are basically like our mini mentors. So if anything, you can ping them as well. They should be quite okay to respond. Yeah. So any closing words, Ayo?
Um, Basically just keep building, right? If you have any question or you're, stoked, the Discord channel is there. You can tag myself or every other Kaya ambassador. We always like available to answer your questions, right? So yeah, pretty much it.
Yeah, so absolutely happy building. Hope everyone's does complete the assignment on time. You still do have a bit of time. It's ending this Friday. Yep, the assignment due date is this Friday. So I think maybe I think it could be people just want to do 1 and 2 and then do the assignment, possibly. We don't know. If it is the case, then yeah, I think that's absolutely fine. Next lesson is on digital assets and tokens. So it'll be, I think technically it's fundamentals part 3, but we wanted to title it a bit differently, because it's more on that specific part. So colloquially, we'll call it fundamentals part 3. Fine. Okay. But officially, we call it digital assets and tokens because that's what it's about, right? So yeah, if there's nothing else, I'd like to thank everyone for all. How many of you guys are here? All 20 of you guys who are here. Uh, all 20 of you guys who are here for attending it live. And as usual, these sessions are recorded. Please do give me a bit of time to settle the recording because Zoom, once it ends, it still takes about an hour to process the video, and then I have to go and edit it and upload it to YouTube. So like I said, bear with me. The recording should be up latest by tomorrow. Then you can go ahead and review it and then do your assignment. Okay. Yeah, like as Eo mentioned, if you face any issues with the assignment or any issues with Discord or whatever, please just contact us. Or contact the ambassadors, whatever. We try our best to respond as quickly as possible because you guys are our priority at the moment. So yeah, you guys have top priority and through the Discord as well. I think we'll keep the Discord even beyond this bootcamp. We'll keep the Discord open, have different waves and stuff like that. So yeah, if there's nothing else, I think we can leave y'all here. Happy building and yeah, take care everyone. Okay,
Bye,
bye.
everyone.